Hi to all. How are you, students? Today's topic is also somewhat related to the capacitors. And now I am going to start the today's topic. The today topic is that before going to today's topic, one question I am giving and then I am going to give the answer for that question also. What is that question? Let us see. Okay. And now this is an identical charged liquid drops, each having radius small r, charge small q and capacity small c, potential v, energy u, surface charge density sigma are combined to form a big drop. Then find the radius, charge, capacity, potential, energy, surface charge density on big drop. This is our question. I will explain. It was very simple, right? And what is our question, right? Then before going to that, I am going to write the answer for this. It was very simple, and in the competitive exams, they may ask the question, okay, based on this. And let us see. And now either in CBSE or in competitive exam there is a chance to get the question from this. And let us see here, and this is, there are n identical drops. Okay, these are n identical drops. There are n drops. How many drops? There are n drops. Charged drops. Every drop has the charge small q and every drop has the radius smaller and every drop has the capacity C, and each drop have the radius smaller, charge small q, capacity C, potential V. Each drop is a charged drop. It also has the energy, that is U, and surface charge density sigma. Okay, and they are combined to form the bigger drop. These all combined to form a bigger drop. This is the bigger drop, right? Now, the radius of the smaller drop is smaller, right? The radius of the smaller drop is smaller, and the radius of the bigger drop is the capital R. The charge on the bigger drop is capital Q. The potential on the bigger drop is V big. These all things we have to find out. And the charge, radius, charge, potential, capacity, energy, surface charge density of the small drop they gave, and when these n smaller drops are combined to form a bigger drop, the bigger drop radius, the bigger drop charge and potential on the bigger drop, surface charge density of the bigger drop, capacity of the bigger drop, we have to find out. That's all. This is our question. On the small drops, everything they gave, when the small drops are combined, then we will get the bigger drop, and then we are going to find out the potential, radius, charge on the bigger drop. It was very simple to find out, right? The first, let us see. These are the small q, radius smaller, okay, radius smaller, small q, and capacity C, and potential V, and energy U, and surface charge density sigma. These are all belongs to small drop, right? Small charged drop. Okay. And when these are all combined to form the bigger drop, right? And this is big drop. This is big drop. And when these are all combined to form the big drop, okay? And these are the n smaller drops. N smaller drops are combined to form the bigger drop. Then the bigger drop radius capital R, charge capital Q, and capacity C big will, and potential V big, and U big, surface charge density on the bigger drop, right? This is related to the information related to big drop. And let us see now. It was very simple to find out, okay? And for example, and there is some charge obeys the additive property, right? And this one has Q1 charge and this one has Q2 charge. When these two are combined to form a bigger drop, then the charge on this is Q1 plus Q2, right? Charge on this is Q1 plus Q2. And charge obeys the additive property. According to that, here two identical combined means Q plus Q, 2Q we will get. And here n identical charges are combined, that's well the total charge we will get as nq. It was very simple. Only 2 drops are combined means 2q, 3 means 3q, n drops are combined, that's well the total charge is nq. Now the first point is that the charge on bigger drop. No, first we can find out the radius. Okay, no problem. Charge on bigger drop we can find out. Charge on bigger drop. Okay, charge on bigger drop is capital Q. That is equal to n into small q. What is n in this? Do you know what is n? Number of drops. Number of smaller identical drops, right? Okay, good. And let us see. And the second point, what we are going to do, the second point, actually first we have to do the radius, but we did the charge, no problem. And the radius we have to find out on the bigger drop. Then find the radius on the bigger drop. Radius on the bigger drop, how to find out? Then before that we can find out the volume of the bigger drop. Okay, volume of bigger drop. Volume of bigger drop. Can you tell the volume of bigger drop? Volume of bigger drop is equal to, okay, for example, its volume is 1 centimeter cube. Its volume is 2 centimeter cube. When these two are combined, the total volume become 3 centimeter cube. Okay, like this, here n drops are combined, each drop having some volume v. Okay, at that moment the total volume of the bigger drop is equal to n times of volume of smaller drop. Volume on the bigger drop, okay, volume of bigger drop equal to n times of volume of smaller drop, right? Because n drops are combined, n smaller drops are combined to form the bigger drop. Bigger drop volume equal to n times of volume of smaller drops. Then what is the formula for the volume of bigger drop? Do you know? The drop is in spherical shape. Drop is in spherical shape. Sphere volume formula is what? The sphere volume formula is 4 by 3 pi r cube, right? 4 by 3 pi capital R cube. This is the volume of bigger drop. That is equal to n times of volume of smaller drop. What is the volume of smaller drop? 4 by 3 pi small r cube. Then this will cancel. Then we will get the capital R cube is equal to n into small r cube. And capital R is equal to, we will get, okay, this is whole power 1 by 3 we have to do on both sides. When we will do whole power 1 by 3, cubed root we have to do, then we will get n power 1 by 3 into small r. This is the formula for the radius of the bigger drop. Okay, and the third point is that we have to find out the capacitance on the bigger drop, right? Capacitance on bigger drop. Capacitance of bigger drop. Capacitance of big drop is what? Do you know the drop? This is a bigger drop. The bigger drop radius is what? Capital R. And the bigger drop capacitance is C big. Okay, this we have to find out. And then what is the formula for the capacitance of the bigger drop? What is the formula for the capacitance? Then one sphere also act as a capacitor. Okay, no need of the capacitor. Capacitor does. It is not compulsory to have the two plates for the capacitor. Even on one metal plate we can store the charge. Anything that will store the charge is said to be a capacitor. Now this sphere also we can tell it as a capacitor. Already we derived the formula for the capacitance of this sphere, and that is 4 pi epsilon naught into capital R, right? It is the radius of the bigger drop. Then capacitance on the bigger drop formula is C big is equal to formula 4 pi epsilon naught into capital R. And capacitance of the smaller drop is formula is what? Capacitance on the smaller drop formula is C is equal to 4 pi epsilon naught into smaller drop radius we have to take. What is the smaller drop radius? Right, there are n smaller drops, each of radius smaller. That means this is the capacitance on the smaller drop. And but we know C big is equal to 4 pi epsilon naught into capital R we write as n power 1 by 3 into small r. Then we will get C big is equal to n power 1 by 3 we can write to a side, n power 1 by 3 we can write to a side, then remaining is 4 pi epsilon naught small r. That 4 pi epsilon naught small r is what? 4 pi epsilon naught small r is small c, right? 4 pi epsilon naught small r, that we know here. That is the capacitance on the bigger sphere is equal to n power 1 by 3 times of capacitance on the smaller sphere, right? Here we got the charge, how many times, and charge on the bigger sphere, radius on the bigger sphere. Third point is capacitance on the bigger sphere. Next, fourth point. What is our fourth point? Do you know? The fourth point is that we have to find out the potential on the bigger sphere, right? Find the radius, charge, potential. Capacity के बाद after the capacity we have to find out the potential on the bigger sphere. Okay, the sphere is act as a capacitor. Now the capacitor potential formula, potential on bigger sphere, right? Potential on bigger sphere. Potential on big sphere, right? What is the formula for the potential? Very simple to find out the potential on the bigger sphere. That is equal to potential basic formula we know, that is V is equal to potential is equal to charge by capacitance, because we know capacitance formula C is equal to Q by V. From this V is equal to we write as Q by C, right? You know this one? And this we write here, potential on the bigger sphere means we have to take the charge on the bigger sphere by capacitance of the bigger sphere we have to take. Is that right? Because bigger sphere potential means bigger sphere charge, bigger sphere capacitance. And here bigger sphere charge we can convert into smaller, that is n into small q by c. Big is n power 1 by 3 into c. And this q by c is what? Q is the charge on the Q is the charge on smaller sphere, smaller drop, okay? Smaller drop. Sphere is a drop here, okay? Sphere is a drop. So whatever that, the drop is in spherical shape, right? And Q is the charge on the small drop, and C is the capacitance of small drop. Then Q by C gives the potential on the small drop, right? Then from this we write n power 1 by n power 1 by 3, we will get a power m by a power n. There is a formula in the mathematics. A power m by a power n is equal to a power m minus n. We have to subtract the powers, 1 minus 1 by 3. That is 2 by 3 we will get. And this Q by C is the potential on the smaller sphere. Then the potential on the bigger sphere is equal to n power 2 by 3 times of potential on the smaller sphere, right? And this is the formula. Potential on the bigger sphere we got as n power 2 by 3 times of potential on smaller sphere. And here we find out the potential. And next we are going to continue. That is, next one is what we have to find out. Look at that. And that we have to find out energy stored, right? And now how to find out the energy? Energy formula is what? Half CV square we can use, okay? We can use the half CV square. Can I rub this? Okay, take a screenshot and note the every point. And next I am going to rub, okay? And now let us see here. We have to find out the energy stored on the bigger drop, right? Now, what is the energy stored on the bigger drop? That is the fifth point I am going to tell. What is that? Energy stored on big drop, right? What is that? C, big. Okay, energy stored on the bigger drop is U. U formula, U on bigger drop. Energy stored on the bigger drop is equal to, energy formula is what? Half CV square we take. C on bigger drop into V on bigger drop square, because we know formula for the energy stored as half CV square. There are several formulas are there. Capacitor energy stored, this is sphere or drop can act as capacitor, right? Drop or sphere, two are same. Okay, sometimes I am telling it as a drop and sometimes I am telling it as sphere. The drop is in spherical shape. Either we can take it as a sphere or drop. Okay, no problem. And the energy stored on the bigger drop is equal to half into C big into V big square. And then energy stored in the bigger drop is equal to half into C big. What is capacitance on the bigger drop? You know that one, right? Here we have to write n power 1 by 3 into small c. And potential on the bigger drop, what? Potential on the bigger drop is this one. Somewhere we find out n power 2 by 3 into V. And now we have to simplify this. And for this, here half into n power 1 by 3, n power 2 by 3. Okay. Something is there here. This is the potential on the bigger drop. N power 2 by 3 V. But here V big we substituted, but whole square is there. We are remembering. We are forgetting that one, right? N power 1 by 3 into C into n power 2 by 3 whole square. N power 4 by 3 into C V power. What you will get? V square we will get. Now U on bigger potential on the bigger drop is equal to half into, or we can write half later. And n power 1 by 3, n power 4 by 3. Now what you will get? N power 5 by 3 we will get, right? We have to add the powers. N power 1 by 3, n power 4 by 3. This base is same, means we have to add the powers. 1 by 3 plus 4 by 3. That is 5 by 3. And next into remaining is what? Half. Here half, here C, here V square. Half C V square. Half C V square. C is the what? Capacitance on the smaller drop. V is the potential on the smaller drop. Half C V square is the energy stored on the smaller drop. Then we will get this equation like this. The energy stored on the bigger drop is equal to n power 5 by 3 times of energy stored on the smaller drop, right? Okay, this is energy stored. And the next question, next one more thing, last one, surface charge density, right? Okay, surface charge density is the sixth point. And surface charge density on the bigger drop. Surface charge density on the bigger drop. What is the surface charge density on the bigger drop, right? And surface charge density formula is what? Charge by surface area. Charge on the surface charge density on the bigger drop. That's why we have to take the charge on the bigger drop by surface area of the bigger drop. Now capital Q we write as small n into okay, we can write capital Q, but the surface area of the bigger drop is what? Bigger drop is in spherical shape. Sphere surface area is 4 pi capital R square. Then Q by capital 4 pi capital R square. Capital R form Q we write as capital Q we write as n into small q. 4 pi capital R formula is what? Here we got somewhere. Okay, capital R formula is n power 1 by 3 into small r. Then when we will simplify this, here n power 1, n power 1 by 3, we will get n power 1 minus 1 by 3, n power 2 by 3 we will get. This is n power 1, this is n power 1 by 3, a power m, a power n. Like this it is there, means we have to subtract the powers, right? 1 minus 1 by 3. 1 minus 1 by 3 is 2 by 3. Into remaining is q by, sorry sir, something is wrong here. R square is there, R square, we have to do the square. And when we will do the square, then what we will get? Let us see here. We will rub this. Okay, let us go for the next step. And the sigma on bigger drop is equal to capital Q is n into small q. We know that one. 4 pi into capital R square. Capital R is what? N power 1 by 3 into small r and whole square. Then we will get n cube by and 4 pi n power 1 by 3 whole square. We will get as n power 2 by 3 into small r square. Now we have to simplify this, right? And now for that, sigma on bigger drop is equal to, here n power 1 we have to take 1 minus 2 by 3. We have to subtract them. N power, what you will get? 1 minus 2 by 3 means we will get 1 by 3. And remaining is q by 4 pi small r square. What is q by 4 pi? Q is the charge on the smaller drop and 4 pi r square is the surface area of the smaller drop. Charge by surface area gives the surface charge density, but that is for the smaller drop. That is surface charge density of the bigger drop is n power 1 by 3 times of surface charge density of smaller drop, right? Okay. And here if you will see something like stabilize this one, okay, what happens to the charge and what happens to the capacitance and what happens to the potential and everything we have to see and take a screenshot and note it properly. Okay, and now let us go for the next topic. Based on this one question we will discuss. Okay, look at here, based on this one application I am going to give, and that problem we have to solve based on this concept, and till now I said I explained some concept, and based on that we have to find out this problem, and I think you may answer the for this question. It was very easy, and we can once we can summarize the 20 minutes discussion. And what is this? And when the smaller drops are combined, then what happens to the charge on the bigger drop, right? What is the charge on the bigger drop? The charge on the bigger drop is, the charge is n into smaller, and the radius is n power 1 by 3. Radius on the bigger drop is n power 1 by 3 times of radius on smaller drop, right? And the next, capacitance. How many? Because capacitance is proportional to radius 4 pi epsilon naught r. How r changes, like that capacitance will changes. The capacitance on the bigger drop is equal to n power 1 by 3 times of capacitance on the smaller drop. And the potential, right? Potential on the bigger drop is n power 2 by 3 times of potential on the smaller drop. And the next, energy stored we derived. Energy stored on the bigger drop is, that is n power 5 by 3 times of energy stored on the smaller drop. And at last we derived the charge, radius, capacitance, potential, energy stored, and surface charge density, right? Surface charge density. What is the surface charge density on the bigger drop is what? Yes, the surface charge density is, can you tell? N power, tell me. 1 by 3 into surface charge density on the smaller drop, right? And this is a summary, and that we discussed till now. And now let us see based on this how to solve the problem. And now the solution is that there are 27 drops. How many drops? 27 drops, and they are combined and they are identical drops. 27 identical drops, each of potential 5 volts. Okay, each of potential 5 volts are combined to form a bigger drop. Then find the potential on the bigger drop. It was very simple problem if you know the formula. In objective also they asked, it is a previous question, right? In the CBSE also they asked this question. And let us see what is the formula, potential on the bigger drop. Yes, if you know formula then it is very easy, and that is n power 2 by 3 times of potential on the smaller drop. Potential on the bigger drop is n power 2 by 3 times of potential on smaller drop. And the potential on the bigger drop is equal to, n value is what? 27 whole power 2 by 3 into potential on the smaller sphere is what? 5. Then we can write this as 3 cube whole power 2 by 3 into 5. Then the potential on the bigger drop is equal to 3 power, this power a power m into n, 3 into 2 by 3, this 3 cancel, 3 square we will get into 5, that is 3 square is what? 9 into 5. Okay, 9 5 is how much? 45. That means potential on the bigger sphere is 45 volt, right? And this is the simple problem. In the exam they may ask the capacitance, they may ask the energy stored, they may ask the surface charge density. You have to remember all formulas. Okay, and now the same question, okay, the same question, if they ask to find the capacitance on the bigger drop, okay, and the capacitance on the smaller drop, the one question I will give, then answer you can give in the comment section. Okay, and that is, there are how many drops? Okay, there are 27 drops. There are 27 drops, and same 27 drops are combined, each of capacitance 12 picofarad, and are combined to form a bigger drop. Then what is the capacitance on the bigger drop? This you can find out, and answer you can give in the comment section. Okay, and also you can find out the surface charge density, and in other also if they will give the data. Okay, you can do only this question. And now let us go for the next one interesting topic I am going to tell, that is, previously we discussed about the series and parallel combination of capacitors, right? Can you tell, take the screenshot and note it. Can you tell what is the formula for the effective capacitance in series combination? The effective capacitance in series combination is 1 by Cs is equal to 1 by C1 plus 1 by C2 plus 1 by C3 and so on. It is similar to the parallel combination of resistors, right? In parallel combination of resistors in 10th class we discussed it, similar to that one it will be there. And now let us see, in series combination like this, if the capacitors are there, okay, this is C1 and C2 and C3, like this the capacitors are there. And now this is first capacitor, first plate, second plate, every capacitor has the two plates, okay, and this is the parallel plate capacitor. Now the second plate connected to the first plate, second plate connected to the first plate and so on, like this. This is series combination. In series combination, if these three capacitors connected, consider as one capacitor whose capacitance is Cs, then the Cs formula, right, effective capacitance formula is 1 by Cs is equal 1 by C1 plus 1 by C2 plus 1 by C3. If these three are in parallel combination, all the first plates are connected to the one point, all the second plates are connected to the another point, right? And now this is the parallel combination. Now if these three capacitors having the capacitances C1, C2, C3, and if they will act as a single capacitor, right, if they will act as a single capacitor whose capacitance is Cp, then what is the formula for the Cp? Yes, it is very simple, C1 plus C2 plus C3, right? And now let this combination, how to find out whether some capacitors are in series or parallel, then that I am going to tell. And before that I will tell some interesting problems, and for that one formula I will give. If there are n identical capacitors, okay, not n identical capacitors, okay, a capacitor has n plates, n identical plates. A capacitor has n identical plates. Each of area, a capacitor has n identical plates. Each of area, capital A. Separation between any two successive plates is small d, comma, full stop. Alternate plates are connected to common point. Then what is the capacitance of that capacitor? Look like this, it will be there. And this is one capacitor, like this, it has many plates. Okay, this is our capacitor. Look at here, and it has some n plates. It has some n plates, 1 2 3 4 5 6 7, like this. N plates are there, 1 2 3 4 5, like this. There are n plates are there. In this alternate plates, and this one and this one and this one, like this alternate plates, and this plate and this plate. Look at here, and these three are connected to one point, and these two are connected to another point. In this moment, and each plate have the area, surface area capital A, right? And the separation between any two successive plates is D. Then what is the formula for the capacitance, right? Here alternate plates are connected together, means if for example if it is gives the plus, and this will become plus plus plus, and this is, if it is minus, then it will become minus minus, right? This is plus 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 because it is connected to plus, and this is also connected to plus 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 plus, and this is minus minus minus. Here how many plates are there? 1 2 3 4 5 plates are there. How many capacitors are forming? 1 2 3 4. That means 5 plates are forming the 4 capacitors. Then how they are connected? In this case they are connected in parallel. Okay, they are connected in parallel. And now in this case we write the total capacitance as n minus 1 into epsilon naught A by D. This is the formula. Okay, and here in this case what is the formula for the capacitance? Capacitance formula is, okay, for the one capacitor epsilon naught A by D. But here how many capacitors are there? 1 2 3 4 capacitors are there. That is 4 epsilon naught A by D. But in terms of one plate capacitance is epsilon naught A by D. There are 4 capacitors there. 1 2 3 4 are there. That's why 4 epsilon naught A by D. But here I want to express in terms of number of capacitors, number of plates. Then I will write this as 5 minus 1 into epsilon naught A by D. Okay, what is the 5? 5 is the number of plates. 1 2 3 4 5. Right? 4 capacitors are there. 1 2 3 4 combinations are there. 1 plus 1 minus is the 1 capacitor. Like this 4 capacitors are there, then 4 epsilon naught A by D. And 4 I am writing as 5 minus 1. What is 5 here? 5 is the number of plates, right? And minus 1 into epsilon naught A by D. Okay, and this is the formula. It was very simple. Okay, and now, and here n plates are there instead of 5 plates. And now the formula will become alternate plates are connected here. 1 2 3 4, there are n plates are there, and alternate plate 1, this one alternate are connected to single point, and this alternate again connected to another point. And now these are, for this capacitance I want to find out. The capacitance is, a capacitor has n identical plates, each of area A, separation between any two successive plates is D, alternate plates are connected to common point, then its capacitance, right? Capacitor not have the 2 plates, here it has n plates, then capacitance formula is n minus 1 into epsilon naught A by D. What is the formula? Can you tell? Right, that is n minus 1 into epsilon naught A by D. This is our, in exam they may ask. Okay, and now here the condition is that alternate plates should be connected together. And now based on this one interesting problem I said to solve. Okay, and I'm going to note it and take the screenshot and note it. The interesting problem is that the question is that, okay, I will pause the camera and write the question. Okay, this is our question. It was very interesting. I like this question. And look at here. There are 4 identical metal plates are located in air at equal distance D. There are 4 identical plates, 1 2 3 4, 1 2 3 4, 1 2 3 4, and each of area capital A, and the separation between the any 2 plates is small d. Okay, and then find the equivalent capacitance. Here the 4 plates are there, we have to find out the capacitance. In the previously we discussed one thing. If n plates are there, okay, like this, a capacitor has n plates, in that alternate plates are connected together, then at that moment the capacitance formula we know. But here alternate plates are not connected together. Look at here, this plate is connected together, but this plate is not connected together. That formula we cannot use. Then in this case, how to solve the problem, right? And let us go to the solution. And first what we have to do, and listen very carefully, I will explain these two problems. And first we can give this x as plus and y is minus. You can consider anything, right? This is plus and this is minus. Okay, I am giving two. There are two terminals are there for the capacitor. One is connected to plus and other is connected to minus of the battery. And when it is connected to the plus, and this will become positive charged, right? It will become positively charged. And when it will gives to the negative, and it will becomes negatively charged. It was very simple, right? And then after that, it is not connected to anywhere, but it is a metal plate. This positive attracts the negatives in the metal plate, right? Negatives in the metal plate. And this positive attracts the negatives in the metal plate. And negatives in the metal plate. And this positive also repels the positives in the metal plate. And this negative attracts the positives. That's when the positives forms this side, right? And like this, the charge will be redistributed. And then this capacitor, this combination, okay. And now we have to draw the equivalent diagram to find out the net capacitance. And how to write the charges? It was very simple. First we are taking x as plus and y as minus. And this is plus means this is totally plus, and this is minus means this is totally minus. But here this plus attracts the minus in this one because we are not giving any charge for this. That's why minus are attracted by this plus. That's where minus forms this side. And this plus also attracts the minus in this because this is also neutral. And then this plus attracts the minus and this plus repels the plus. That's why minus will forms at the near end of this one, and then the plus will forms at the far end. Okay, on the other end, this plus minus 1 capacitor, this plus minus 1 capacitor, this plus minus 1 capacitor. That means it will act as a 3 capacitors, but the effective capacitance how to find out? First we have to draw the equivalent diagram for this. Okay, that is very important. Okay, and first we start from x. We are starting from x, and then after that x goes to the second plate, right? Okay, we will draw x goes to the second plate. This is the second plate, and second plate and first plate combinedly act as one capacitor, right? Okay, first plate. And after that, this x goes to the second plate, and second and third also act as one capacitor. That means x also goes to, okay, second plate and third plate, and x I will take as again second plate like this. Okay, because second one plate we can split as like two plates. Okay, and this second are connected. Second means only one. These two are one. Okay, this 2 is 1 only. Okay, this 2 means only 1 connected to x. This 2 connected to x, right? 2 is only 2, and 2 3 is the combination 1 capacitor, right? 2 3 combination 1 capacitor. Then after that, what we have to do, when these two capacitors completed, 1 and 3 are connected, right, with a wire. This 1 plate and this is 3 plate. There are 4 plates, are 1 2 3 4, but the 1 and 3 plates are connected with a wire. That means 1 and 3 plates are connected with a wire, right? 1 and 3 plates are connected with a wire. And then after that, 3 and 4 will act as another capacitor. Okay, and 3 is here, there, this 3 and one more, this will also act as 3. When we will take the wire from the 3, then this also act as 3 and 1 both are same, right? Either you may take it as 1 also. Okay, you may take it as 3 also, because 3 4 acts as one capacitor. That's why I took it as 3. Okay, and then after that, 3 and 4 act as one capacitor. Okay, and now why I am taking it as 3? Because from the 3 we are taking the wire. Okay, then this is 3, and you may take it as 3 from the 1 also it is coming. You may take it as 1 also, because 1 3 are connected, they have the same charge, right? And now 3 4 here also minus plus will be there, and now this is fourth end is connected to the y, right? Okay, completed. 3 capacitors are there, identical these are, because separation is same, plate area is same. Okay, and these two are how they are in parallel. In parallel, what we have to do? We have to find out the effective capacitance between x and y. these two are in parallel. In parallel, we have to add them, right? Okay, this is the effective capacitance Cp. Okay, Cp. What you will get the effective capacitance of these two? We have to add them, C plus C. What you will get? 2C, right? And now this is Cp, effective capacitance. Here we will get like this. This is X and this is Cp and this is C, right? And look at here, these two are parallel. That's why effective capacitance is Cp we are getting. Just we have to add in parallel C1 plus C2. And this is C and the XY. Effective capacitance between X and Y we have to find out. Then Cp and C are in series, right? And then what is the formula for the effective capacitance between X and Y? Cs, that is C1 C2 by C1 plus C2, right? Then CPC by Cp plus Cv, right? Cp is what? Cp is what? 2C, right? Cp is 2C. 2C into C1 C2 by C1 plus C2. These two are in series. Effective capacitance C1 C2 by C1 plus C2, right? 2C into C by 2C plus C. Then what you will get? 2C square by 3C. And then what you will get? 2 by 3C. But what is C? C is the capacitance, right? And capacitance of the one plate, one capacitor. This is one capacitor. Separation is D, area is A. Then capacitance formula, epsilon naught A by D. Then what you are getting? 2 by 3 epsilon naught A by D. Right? It was very interesting now. Then if you will get any doubt, you can ask me once again. And I am going to explain one more problem. You will get the clarity, right? Let us see. What we have to do first? First we have to assign the charges. Okay, and there are here 4 plates are there. This X I will give as plus and Y I will give as minus. And now effective capacitance we have to find out. There are 4 plates are there. 4 plates are there. And now let us see. And for that, first what we have to do it here. First we have to give the charges, right? And this X is plus. This will become complete plus because we are giving the plus, right? Okay, good. And this also plus. And this is minus. Minus means this will become minus. Right? And now, how many capacitors are there here? Plus minus 1 capacitor and plus minus 1 capacitor. Only 2 capacitors are there, right? And now let us see how to simplify this. How to simplify this? We have to draw the equivalent diagram. First we have to write the charge distribution. Then after that we have to draw the equivalent diagram, right? How to draw the equivalent diagram? Can you tell? It was very simple, no? Yes, it was very simple. Let us see how to solve. You start from X. Okay, X I am starting. And X goes to what? One plate, plate 1. Okay, I will draw the plate 1. And 1 is along with 1, 2 act as one capacitor, right? Okay, completed. And then after that, you also start from X. X also goes to 4 also. X not only goes to 1, X also goes to 4. Right, X also goes to 1 and next X goes to 4. Right? And this 4 and 3 will act as one capacitor, right? Okay. And then after that 2, 3 are combined, right? This is 2, this is 3, this is combined. And then they are connected to Y, right? Other end Y. Simple, right? The 2 capacitors only. And the effective capacitance is what? Effective capacitance between X and Y. And this capacitance C, this capacitance C. In parallel combination, we have to add them, right? C plus C. That is 2C. That is 2 into C is what? C is the epsilon naught A by D. It was very simple, right? And now, you can solve this question C. And answer, you can give me in the comment. And if you will get any doubt in my lecture, and you can consult me in my WhatsApp number. My WhatsApp number is 9963817138. Okay, and also you can express your doubts in the comment box, and then I will answer in the next lecture. Okay, thank you for subscribing my channel, and thank you for watching my lectures. I am expecting from you more likes for the my lecture. Okay, I am expecting the likes, and if you like my lectures, compulsory you have to press the like and share to your friends. Subscribe my channel, press the bell icon. Thank you for watching my videos.